And tangent is, of course, now, do these values, the numbers you would put in there, change ever if you, oh, that's a crap drawing. If you spin that triangle around, turn it upside down, inside out, sideways, will these ever change? No, they will not, because the theta is simply your starting point, yes? All right, now again, a great many of you already know what we're doing right now, but that's okay. What do you see right there? It's an x and a y axis, yes? It's a coordinate grid or the Cartesian plane, yes? Everybody cool? All right, now, if I take all of you right now, put a dot anywhere in the first quadrant. Now, it's possible you don't know where the first quadrant is. That's okay. If you don't know where the first quadrant is, don't put a dot anywhere on here and wait a second. Everybody else, put a dot. All right, that should be long enough to put a dot. This is the first quadrant. In the first quadrant, x and y are both greater than or equal to 0. Meaning they're both positive. Everybody cool? So you would have a dot somewhere there, yes? Everybody agree? Okay. Connect that dot to the origin. So all of you should have done that, yes? You getting dripped on? You getting dripped on? Again, the ceiling leaks. All right. Now, of course, my shaky brain surgeon hand did not draw a good straight line there, but all of you, because you're young and fit, have an exactly perfect straight line there, yes? Of course you do. Now, right now, you should notice that you have two sides of a right angle triangle, yes? If you drop this straight down, you will make a right angle triangle. Agreed? Which gives you something we could do trig with, yes? Where would you put theta? Right there, okay. Which makes this what? Opposite. And it makes this what? Adjacent. Everybody cool? Everybody cool? All right. Now, please put a point in quadrant 2. Again, if you aren't sure how that works, just wait a second and we'll do that. There is quadrant 2, yes? Connect it to the origin. And what do you notice you have made? Two sides of a right angle triangle, yes? Connect it. Now, how does quadrant 2 differ from quadrant 1? X's are less than 0, and what are Y's? Greater than 0. Everybody cool? Okay. Where must you put theta here in order to be able to do trig? I must put it there, yes? Because I need a 90-degree triangle, right? So, what does that make this side? Adjacent. What does that make this side? Opposite. Everybody cool? Okay. Put a dot in 3. Make your triangle. How does quadrant 3 differ from 2 and 1? X is less than 0, and y is less than 0. Agreed? Theta has to live there. That's still A, that's still O, yes? And lastly, I'm just going to change this first drawing and I'll put the adjacent inside. Quadrant 4, x is greater than 0, y is less than 0. Theta's there, there's your A, there's your O. Is everybody cool? Now, you should have noticed that we made 4 angles, and they all shared some characteristics, yes? What characteristics did they share? Manru, give me one. Well, in a perfect world, I would have drawn them exactly the same, but I don't have a ruler or a protractor, but okay. So let's assume all those thetas are the same. Fine. What else do they share? Just look at those 4 triangles we drew. Tell me things they share. They all make a right angle triangle. Okay.
They all share the same origin.
They all start from the origin, yes? All right. And you will notice that where does the one line goes along what? The adjacent line is where? On the x-axis. So let's read this next point. An angle is in standard position if its vertex is at the origin. What's the vertex of an angle? Oh. Well, Manru. Holy crap. What's the vertex of that parabola? The point where it turns around. So what must be the vertex of that angle? The point where it turns around. So, the vertex is at the origin. Are all of these thetas have their vertex at the origin? Yes or no? Yes. And, now this is where it gets tricky. This is going to be a new word for some of you. Oh, damn. I didn't want that to happen. Damn. The initial ray lies along the positive x-axis. Now let's stop for a moment here. Right? Which of those 4 colors of theta right now is an angle that is in standard position? You got 4 colors there. Black, red, blue, green. Which is the only one that is in standard position? The black one. Why? It starts on the positive, and after its vertex, it's up here, yes? Why is the red one not in standard position? Because it does not start on the positive x-axis. Everybody understand? Now, if I wanted to do the proper angle that goes with that red, where must I start? If I want the red theta to have something to do with an angle in standard position, where must I start counting from? Because right now I've started counting from here to make red theta, haven't I? And that's no good, because that's not the positive x-axis. Where would I start counting? Here. So red theta is not in standard position, but red theta's buddy, and I'll use a similar shade, starting from 0 up to there, pink theta is. Is everybody cool? All right. So initial ray is always on the x-axis, positive x-axis. The terminal arm is the other end of your angle. All right? So that terminal arm, if the angle is in standard position, must be all of these hypotenuses. Yes? Is everybody with me? Now, if standard position means we start counting from the positive x-axis, this is where all our angles have to start from. And if we go counterclockwise, or in Britain, anti-clockwise, counterclockwise means it's a positive angle. So is pink theta positive or negative? Positive, because I went counterclockwise. Everybody cool? Is light blue theta positive or negative? Positive, because I went counterclockwise. Is light green theta positive or negative? Positive, because I went counterclockwise. Now, if I go the other way, you're smart kids. If I go all the way around this circle, how far have I gone? 360 degrees, yes? So this green theta must be a very big number, yes? Or it's a very small negative number. Because if I went clockwise from 0, this would be negative. Is everybody cool? Everybody's good? You always start here, and it just depends on which way you draw your arrow. Now, the more astute members of the class will notice that this green terminal arm here actually gives you how many angles? 2. It gives you the positive one and the negative one. Which is the one we need to be able to do trig? Light green theta or dark green theta? Dark green theta, because dark green theta makes the 90-degree triangle. Is everybody cool? Okay, we're going to spend like 3 or 4 days on this if you're not quite cool right now. Everybody good? All right, so we're going to start real easy. Sketch. What does sketch mean? Just draw it. No rulers, no protractors. Just tell me what a 30-degree angle in standard position would look like. Just draw that one. Go. All right. For an angle to be in standard position, where must it start? Where must it start? From the origin, and the first line goes where? Along which axis? The x-axis in which direction? To the right, positive. Now, is that a positive angle? So what direction do I count from there? Counterclockwise or clockwise? Counterclockwise, which means I go this way, yes? How far do I go? 30. Now, what's straight up? 90. What's half of 90? 45. So I don't even want to go halfway. It would look something like that. Is everybody cool? Everyone is good? All right. B. Where does it start? Origin. Where does the initial arm go? To the right. Is that a positive number? So where do I go? Up or down? Up. And how far do I go counterclockwise? How far is that? 90. Do I need to go more than 90? How much more? 45 more. So now this is my 135. Does everybody understand? Everybody? Okay, do the next 4. Go. While you are doing the next 4, I'm going to sketch 2 more at the bottom, and I want you to do them when you get to them. Is everybody good? So what is the difference for G and H? They are negative. So I still start out here, and then where do I go? Down 70 degrees. What about H? I start there and go where? Down, or count clockwise, 90, and then 20 more. It would be out that way at negative 110 degrees. Now, the more astute members of the class should notice that if I were to go up to letter C, and I said letter C was 245 going this way, what is it going that way? Negative 115. Does everybody understand how this works? You can get to it going positive, which we add from 0, or you can get to go at negative, which means we subtract from 360. So this guy is negative 70 or positive 290. What is this guy? Negative 110 or positive? You said 250, right? Okay. Just making sure. I listened to you twice. I swear you said 350, and I knew that you wouldn't have said that, Sam. That's why I said, you said 250, right? Is everybody good? It's a circle. We add or we subtract. Is everybody good? All right. Turn the page over to 192. Now, new word, the reference angle. The reference angle is the angle that is between the terminal arm and the nearest x-axis. it's the angle we need for trig. All right? So in this first one here, we're going to do the easiest one. I want you to draw me an angle in standard form, or in standard position, of 60 degrees. Where would it be? If an angle's in standard position, where does it start? And then draw 60 degrees. Everybody should be done now. It will look like this, yes? Agreed? I don't need those arrows there. I'm just going to draw that. Everybody cool? Where is the 60 degrees? Pink dot or dusty gold dot? Dusty gold dot. Absolutely. Now, there is my 60. Now, you people are intelligent. Which is the terminal arm? Is it the pink arm or is it the light blue arm? Pink arm is the terminal arm, yes? Now you will notice that that pink arm is closest to here, yes? So, this is 60, but it's also its own reference angle. Does everybody see that? Because this terminal arm is closest to this x-axis, the 60 degrees, that is the angle that we cared about, is also its own reference angle. Everybody good? And of course, if I wanted to do trig, and I dropped that line right there, I could do trig with that 60, couldn't I? Everybody good? All right. Now, give me an angle of 150. Where will it be? It'll be in the second quadrant, yes? It'll be out here, agreed? Okay. Where is the 150? Red dot or green dot? Red dot. So this is the 150. Where is the terminal arm? Red arm or blue arm? Red arm. Where is that red arm closest to for an x-axis? The negative x-axis, yes? Which means this is where my reference angle lives. And what is it? Reference angle, and it is 30 degrees. Can I do trig on the right side of this terminal arm? No, because I don't have a 90-degree triangle. Right? But I do over here. So my reference angle becomes the angle we need for trig. Everybody cool? All right. So now give me one at 215 degrees. Where would that be? Third quadrant. Now, all I want from you now is put a little r where the reference angle is. The angle we would need to be able to do trig. Where will it go? I'm going to put a few dots on here. Where's the R? The orange dot, the last dot I made. There is the reference angle. Everybody cool? Okay. Negative 85 for the last one. Where's that going to be? In the fourth quadrant. Really close to there, yeah? Okay. Where's the reference angle? I'm going to put some colors in again. Oops, that should have been red. Well, it's blue. Purple, dark blue, and highlighter green. Where's the reference angle? Red. Because it's only between the terminal arm and the x-axis. Even though this is only 5 degrees away from the y-axis has nothing to do with the reference angles. Okay? Okay. Now, take all that knowledge that you just had, right? And do those 4 questions. Go. I want the standard position and the reference and the values of the reference. First quadrant. Where's the 15 go? Inside. What's the reference angle? Also 15 degrees. Could I do trig with it? Yep. All right. Where's this guy going? Second quadrant. Out here. Where's the 120? Right or left of the terminal arm? The 120 is to the left. There's the 120. What's the reference angle? 60. Excellent. What about this one? Third quadrant. Where is the 250? Above or below? Where? There's the 250 all the way to there. What's the reference angle? 70 in there. Because when I follow the purple circle, halfway around a circle is what? 180, and then I had to get to 250, so there's the other 70. And lastly, where's the 350? Where's the 350? All the way around. And what's the reference angle? 10. Yeah? Yeah. Now, you will notice that even though 3 or 4 chapters in our discussion today ago, I mentioned the coordinate grid, yes? But I haven't really talked about it, have I? We're going to talk about it now. Where would the angle in standard position be if this point is on the terminal arm? What? We'll do this one together, then I'm going to make you do them. Where is 3, 2? On the coordinate grid. In what quadrant? First quadrant. 3, 2. There it is. There's the angle. Everybody understand? In the first quadrant, is the reference angle the same as the standard position angle? Yes. So we're going to put an S for standard and an R for reference. Everybody cool? Okay. Where is it going to be in B? -5, -1, right there, yeah? Right? There's the S, there's the R. I should have made that bigger. I know that's further, right, than 1 down, right? -5, -1. But for graphing purposes, S, there's the R. See what I mean? I need to make it bigger for drawing. Everybody cool? Do the next 4. Go. Next 5. Next 6. Tough to count today. It's first day back. Got to ease your way in like the kindergartners. Riley May. She's in the other class. Never mind. She's in the other class. I was just looking at her. She was sitting right there. I need to talk to her. If any of you see Ms. Riley May Willems out in the hall, send her to me. Tell her she's not in trouble. What do you know about E, F, G, and H? Without doing any calculations, you should be able to tell me something about E, F, G, and H. No, only E has 4 and 2. F is -4 and 2. G is -4 and -2. H is 4 and -2. Manru. They're in every quadrant. That's something you could tell me. What else? I'll make it slightly easier because we're easing in because it's first day back. What must be the same in E, F, G, and H? Which angle? The reference angle must be the same in all of them, mustn't it? Right? Okay. Do reference angles have a positive or a negative about them? No. Because we're just doing trig, right? If I were to take my whitey out pen and do this, isn't that just a grade 10 triangle that we would work with? Right? Does everybody understand? Everybody cool? All right. Your work is page 193. There is more than enough room on this page to do all the answers. On this page. And you have 14 minutes with which to work. Should anybody have any homework? No, you should